Hi everyone, welcome back to my next video in the cybersecurity series. So just to give you a very short catch up, so this is the topology which we are working on. We have a 192.168.1.0 network which has a Windows server and a Windows client, and then we have a 192.168.2.0 network which is a Linux network and a Linux client. Both the networks can talk to each other. It is stated that VPN is a key here, but uh, I don't think we have VPN there. But anyways, we can also look if the VPN services are up and running. And then we also have all these networks directly connected to the internet. Here we are simulating it, so it is a NAT or NAT network or a bridge network which you use to connect directly to the internet here. And then we also have a security operating system, which is in our case we use Kali Linux, and that is connected to 192.168.1.0 network with an IP address of 1.2, and that can also successfully reach out to all the machines in the network. So this is what we have, and with that information we are going into this video. So here what we are going to do is we are trying to do some scans to the network and then try to find out, identify what are the different services which we have and how the services are working. So what ports are there, kind of thing. So this is in continuation with the footprinting and reconnaissance which we did in our previous videos, where we passively tried to look at what are the hops, just try to map the network, how many machines are there, how they are connected, what are the uh, gateways and kind of things. We assumed that we all the footprinting and reconnaissance, they're all just to give you an idea. However, it could be a trap as well. It could be a different. It could be different from the original case as well. So it is very important for you to do more add-on checks and then confirm it. So we are still in confirming stage. We haven't went attempted to exploit the network or try to reach into the network, into the systems. We are still working on getting further information. So at this point, after doing footprinting and reconnaissance, we will move forward to do some scan to confirm what we have seen is the correct, to identify some of the services, to identify some of the ports and others. But before we go into that, I would like to introduce you to one of the tools here. It's a packet capturing tools. So here you could see that yeah, it's the Wireshark. It's a packet capturing tool here. So we are going to use Wireshark to capture the packets which are coming into the network, into the interfaces, just to make sure that to understand further. This is one of the wonderful packet capturing tools. So you could see that it lists now we are in a SDC. So you could see that it can list the traffic. There are traffic which goes through the internet, and internet is literally the NAT network. You could see that it says 10.0.2.15. And then I have a adapter for a loopback traffic, which is 127.0.0.1. I have external and internal network, so which is 192.168.1.1 and 20.0.0.1. Let's see how this works. So initially, let's go with the Swansea, the internal network. I double clicked it, which means I selected that particular interface. It is going to observe the packets. It is going to capture the packets which are coming into 192.168.1.1, which is the internal Swansea network here. You could see that there are no packet captures, no nothing, no traffic is at all. So let's go back to our Kali here. Let's try to generate the packets. Let's try to generate some network captures here. So I'm in a terminal here. Let's go with ping 192.168.1.1. So let's go with the 4 packets here, and then go back to our packet capture. So you could see that I'm stopping the packet capture here. So this is a start and this is a stop. So you could see that the moment I issued my ping, it says that there is a packet which comes from 192.168.1.1. It goes to, I'm sorry, 1.2, which is the Kali Linux, to 1.1. It is a ICMP and has 98 length. So when it is 98 here, just wanted to go back and remind you about the previous ones, previous activity where we tried to do some ping tests. You can manipulate these packets as well. So it gives some information as well. And then there was an ARP request coming in who is having 192.168.1.2, and then 1.2 is getting a reply as well. This is the ARP, the basic ARP which is happening. And then from 1.1, that is a response to 1.2, again 1.2 to 1.1. So this is the second one, this is the third one, and this is the fourth one. So totally there are four ping packets which is going up and down, and you can see those information here. And then there is an ARP as well. You can also deep dive and see further more informations here. So let's see that frame 10, there are 98 bits on the wire, 98 bytes captured. You could see the what is the interface ID, when was it arrived. So this is the information about the frame, and here is Ethernet to information. So the destination is 4.99 and the source is B0. So this should be, if we can go here and ipconfig, this should be 192.168.1.1. So this is the MAC address of this guy is 8CB0. So you could see that the source is from ACB0, and the destination is to F999. This should be the Kali Linux. So because the source is here, the destination is here. So this is the Ethernet 2, which is the layer 2 details of it. And then here you have the layer 3 details, which is the IP addresses. Every time we say that in layer 2, it's only MAC addresses which is going on and up. It's only, the communication is based on MAC address, and then the physical address, and then layer 3 is where the IP addresses are dealt with. So here you can see the IP packets here, the destinations and the source. And here is something which is important. It says that the total length is 84. Oh, sorry. Um, mm, and then the time to live here is 128. Okay, and the protocol used is ICMP. These are the source. And what is the ICMP message? It's that. So you can literally look at the packet and monitor the packet. Look what is inside the packet. And you can go in here to see that. If I'm just going to click 192.168.1.2, and it would have the same information, but here you should be seeing that the time to live is 64. So this is something which I would like you to go and refer. So when it is from 192.168.1.1, it goes off, the time to live is 128. And when it is from 1.2 to 1.1, which is a Linux version, the time to live is 64. Something you can further get information as well. Right. So with this is what packet capture is. This is going to be really important for you in case of um, if you're going to work on the packets, and to um, you know you're going to observe the packets, you're going to look at what is happening. So Wireshark is going to be really a fancy tool for you as well. So let's go into the London network here. Let's see if I have my nmap installed. Yeah, I have my nmap install. If you don't have your nmap install, you can go and install nmap, use sudo apt install and then nmap, and then you can install it. So I have it installed, uh, so I'm not going to install. So it says that name is already, nmap is already the newest version. So anything which you don't have it, if you have an error, you can do nmap. um, I mean, you can install it as well. So let's go here. I'm just going to say if I have T-Shark. T-Shark is one of the, it's a Wireshark. It's a CLI version of Wireshark. So I have that. So let's go to my IP address here. All my IP addresses are up. Uh, right. Before I go and issue my ping, let's go back to this guy and let me say that I'm not going to capture the internal, I'm going to capture the external, which is 192.168.1.1. So let me save it just for my for our purposes. So we can save it as a pcap ng file as well. Ping capture Kali to STC. Right. So it has now started to capture the Linux ones here. So let me ping 192. Okay, before I ping, I just wanted to capture the packets here as well. So let's say sudo tshark and then enp0. So I'm going to capture the 20.0 network, which is enp0s9. So running as a root capture. So it is now ready to capture. Let's initially do a ping from here. Ping 192.168.2.1. You could see that here it started the capture. It is going from 20 to 2.1 and 2.1 to 2. So there are packet captures which are happening. Let's go here and you could see that the T-Shark has also captured the packets here in the Linux machines. Uh, so you could see from 20.0.0.1 it comes in, because the other interface here is 20.0.0.1. It is not showing 192.168.1.1 because it shows only 20.0.0.1 because that is where it comes from. And you could see that there are different ARP protocols as well which is going on. So this is how you can, if you want to observe the packets in a Linux in a CLI mode, you can work on it this way as well. So let me cancel it and ping 192.168.1.1 and just canceling with 3 packets, just to make sure that we can understand the packet captures here. So you could see that I should be having the packet. So if you have a lot of packets here, usually which you have, and you wanted to get a specific type of packets, what you can do is you can use here. You just want ICMP packets, you just click on ICMP packets. You can only see the ICMP packets, or you can filters, you can apply filters here. So I would say IP source address for me is going to be 192.168.2.1. So here I have 2.1, and its destination here says 20.0.0 because that is the interface which we are now looking at, and that's what it is getting up with us. So you could see if it is 20.2 192.168.2.1, it comes to 20.1. You can see the TTL is 64 here. It's all 64s here because it is all from the Linux machines, and move on. So This is how you can work on packet captures. So the Wireshark is one of the powerful tools which we have, which you can use it to monitor the traffic packets and then understand what actually the commands which you're issuing is to move on.